So earlier, we saw that the square root of a negative number is undefined in the real numbers. But sometimes it can be useful to work with them anyway. They turn up as solutions to quadratic equations. They turn up in other places. We'd like to be able to describe the square roots of negative numbers. What we do in order to be able to describe them is we create a new number called I. The new number I is defined to be a square root of negative 1. That is, its definition is I squared equals negative 1. What do we know about this number? Well, it's pretty clear that I is not a real number, because any real number, if we square it, we get either something positive or 0. We call I an imaginary number. And then we'd like to be able to do arithmetic with I and all of the real numbers that we started out with. So we can multiply a real number times I. If we multiply a real number b times I, we get the imaginary number bi, and we just write it as number times I. So for example, 5 times I, we would just write 5i. And we can add an imaginary number, b times I, to a real number, a, to get the complex number, a plus bi. Notice, no rule says that a and b can't be 0. So all real numbers and all imaginary numbers are also complex numbers. For the set of all complex numbers, we write this blackboard caps capital C. Recall, we write a blackboard capital R for the set of all real numbers. Now it turns out that this one property that we know, I squared equals negative 1, is enough to get us everything we could possibly want about the arithmetic of complex numbers. The simplest thing that it gets us is the ability to take powers of I really easily. So finding powers of I. Let's start out with I to the first power equals I. Just like real numbers, imaginary numbers obey the rule that anything to the first power is just the thing itself. And then I squared, we know just by definition, is negative 1. That's what it means to be I. I to the third, if powers of I are to mean what they mean for real numbers, well, that's going to be just I squared times I. I squared we know is negative 1. So this is going to be just negative 1 times I, or negative I. I to the fourth, well, that's going to be I to the third times I. I to the third we just said was negative I. So multiplication is associative. I times I is negative 1. So I to the fourth is positive 1. What should I to the fifth be? Well, that's going to be I to the fourth times I. That's going to be just I. Do you see the pattern that we're going to get here? Every time we multiply by I, we're going to go one step around a circle. I to the first, I to the second, I to the third, I to the fourth, I to the fifth, I to the sixth, I to the seventh, I to the eighth. If I wanted to find I to the 15th, I could, this is not typically how I'll do this, but I could count out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 steps around this circle, and I would get negative I. All right, that was a little bit tiresome for 15. If I wanted to find I to the 337th. Yeah, that method isn't going to work. Let me think about how this worked out. Right. I have I to the 15th back here. That means I went the whole 4-step circle a few times, and then some extra steps. I noticed that 15 is 3 times 4 plus 3. So I went around the circle 3 times, 4, 8, 12, and then 3 more steps. I to the 15th is the same as I to the 3rd. This suggests a technique that we can always use when we're taking some power of I. First, we find the remainder when n is divided by 4. What do I mean by the remainder? I mean what's left over when we make as many groups of 4 as possible. This is the remainder that we find when we do long division. And then I to the n is just the same as I to the power of whatever that remainder is. So to find I to the 337th, I will divide 4 into 337. 4 goes into 33 8 times. 4 goes into 17 4 times. And the remainder is 1. So the remainder is 1. I to the 337th is equal to I to the 1, which is just I. All right, let me show you how to find remainders using a calculator. There are several ways to go about this, and some of them are really complicated. I'm going to show you the simplest possible way. So let's say I want to find I to the 875th. And why not? I need to divide 4 into 875. So I'm going to do that on my calculator, just in the usual way. 875 divided by 4, that gives me 218 and a decimal. So I get 218 complete groups of 4. 218 complete groups of 4 uses up 218 times 4, or 872 of my things. Subtracting, I see that I have 3 left. So my remainder is 3. So I to the 875 is the same as I to the 3rd, which I know is 1, 2, 3, negative I. I'm going to have you try one of these now. Find I to the 17th. Pause the video and try this now. All right. Well, I to the 17th, that's going to be the same as 4 goes into 17 4 times, with 1 left over. So that's going to be the same as I to the 1, which is just I. We can also take negative powers of I. We could, for example, take I to the negative 18. Just by definition, that means 1 over I to the 18. What do I want to do here? Here I want to make my denominator 1. So I want to multiply my numerator and denominator by some power of I so that my denominator is 1. That is, so that the power of I in the denominator is a multiple of 4. So here's what I do. I look at the remainder when I divide 18 by 4. 4 goes into 18 4 times, with 2 left over. In order to get another whole group of 4, I need to add 2 more on. 2, 3, 4. So 18 plus 2 is 20. And 20 divided by 4 is 5, remainder 0. So I want to get 2 more i's in the numerator and denominator. Now my denominator is just 1. This is I squared, which is negative 1. I'm going to show you another example. Let's say I have I to the negative 87. So that's 1 over I to the 87. Now when I divide 87 by 4, 4 goes into 87 according to my calculator 21 times, using up 84 things, with 3 left over. So in order to get up to the next multiple of 4, I need to add 1. 87 plus 1 is 88. And sure enough, 88 divided by 4 is 22, and no remainder. So I need to multiply my numerator and denominator by 1 more copy of I. My denominator then becomes 1, and I'm just left with I. I to the first is I. I'm going to have you try one of these as well. Find I to the negative 37. Pause the video and try this now. All right, I to the negative 37, that's 1 over I to the 37. 4 goes into 37 9 times, using up 36 things, with 1 left over. What do I need to add to 1 in order to get 4? Well, 3. So I'll have 37 plus 3 is 40. And sure enough, 40 divided by 4 is 10, remainder 0. So I want to multiply my numerator and denominator by I to the third. So this is I to the third. That's 1, 2, 3. So that's negative I.